This is a demo video about Memfault's Issues in Traces feature. We're going to dive into an assert and a hard fault that was experienced on one of our devices in our office. The first one we're going to look at is this function, PRV recursive crash. It happened across two releases, 101 and 100, and it happened 2 days ago. There were two instances of this crash across two different unique devices. Let's dive into more details. At the very top, you can see the information that was shown in the menu, but we show more details down below. We'll show you all of the backtraces for all of the threads that were currently running at the time of the crash. Let's open up the assert handler. You can see that the program counter is still valid. This frame took 24 bytes on the stack, and it was a normal frame. The arguments that were passed to the function were registers because it was an assert handler, and the local variables was actually a struct on the stack called info. Expanding one of the other frames, we can see a little bit different of information. The arguments was depth because we were calling it recursively. We have another local variable. At the very bottom, we'll show you the ARM fault status registers, if there were any valid, and we'll show you the registers at the time of the crash. Let's go look at one more crash, but this one was actually a hard fault. So this hard fault accessed a bad address. And we'll be able to find that out by decoding the ARM fault status register for you. Most people just know these values and they don't know how to decode them, but we'll actually give you human readable output based on them.